thing I want to say. So I know you have the problem with the re-release, right? I also cannot solve it. I emailed Synopsys already. I don't know if they will get back fast. But the point is that if you look at the library, we actually had this project created from there, right? It is from this memory. And then SRAM FinFET 25 nanometer. You'll see that this project was based on that when we create the SRAM cell, right? If I right click the command and you go to the all the way to the end, you see that these are exactly the command what we are doing, right? So I try to run this this application library, but it works well. So there's no problem with the command itself. It can be that we did some modification and it was okay in the old uh, release, but now it's not working. But here is showing the 60 SRAM cell, right? Do you see that? So what did we do actually? So I asked you to install the Silicon Workbench. So if you had done the what I said earlier, you go to extension. Now you can open the Silicon Workbench. This is the first time I use it, but in this new release, they start consolidate with this. In the past, they use something called ICWBEV, and then they use IC Validator Workbench. But now they say use this one. If you go to the S process, right, menu, there's a chapter tell you how to use this layout tool, right? If you go to S process, and then you just search for Silicon Workbench, or they have a command SIWB, right? Silicon Workbench. So this brings you to chapter 12, right? So you use the release menu, go to chapter 12, right? And it will teach you how to use this Silicon Workbench. So these are the commands I sent you earlier, together with S process to create the structure. Okay, is this clear for now? Okay, so let's take a look what we were doing, right? So if I go back to Silicon Workbench, my goal is to open the GDS. Since this is in the installation directory, so I will just copy it, right? I go to the folder as lsgds, and then it has more than that actually. It actually have a GDS file, a markup file, and this .mac file, right? So I'm going to copy this to my home directory so it will be easier for me to open. I think I probably can do it use other way, but I just copy it. So if you clear, right, you browse, and then I will, oh, actually no need because it is here already. So I will just open from here directly. I look at this LYTMAC. So now you see that it opened this GDS, right? You know GDS, right? Because you took E1 to 26, you probably also took other classes. But this is not Cadence, right? This is just using Synopsys tool. And from here, it tells you all the layers. Do you see that? On the right, right? Now, what's special about TCAD is that you give this whole thing, it can simulate the whole device and whole structure. Then this gives you the SRAM. So if you look at the input command here, you go to very beginning, right? You say that, okay, I'm going to open this fin SRAM lyt.map, right? But you don't know which to simulate. here it say if the domain equal to SRAM 10T. So here is this SRAM 10T. Do you see this box? This is something that called highlight. You can always draw something for yourself. Let's say I only want to simulate this region. Then now it calls Sim 3D 36. You can change the name. Although I forgot how to change it. Yeah, but yeah, read the menu, you can change the name also. Okay. So for example, you can change here, right? You can change the domain name here to what you just created instead of SRAM 10T, right? Then you will only simulate that small domain. That's one thing, right? So now go back to our project. So this example, although they only simulate SRAM 10T, but if you look at here, it also have a domain just for the NMOS and PMOS, TN and TP. Okay, so if we go back to our project, where's our project? So our project is in here, right? Right, this is the NMOS and device that you just did, right? But obviously, is it this one? Yeah. But obviously, what we did is actually we changed the size of this one instead of having another name. So let me show you what I mean. So I'm going to again open the layout viewer. I just open another one because this can save me time to locate to the right directory. And then I just open, browse, right? So now I am in the right directory. I look at this SRAM layout map, right? Do you see that? So at that time we were lazy. We cut the GDS. We only cut the FinFET in this part, right? First we delete most of the content, right? This was the old content, right? The whole SRAM. This one, if you try to compare, you see that it basically is this part, the top part. Let me see if that's the top part. Actually, it might not even be that part. Yeah. This actually we recreated, and maybe we have now. We can measure the length also. How do I do ruler? Right, for example, this is the poly. Oh, look, this is the fin, right? And this is the poly, I think. This is 20 nanometer, right? And then the fin width is 7 nanometer. This is fin, right? Top is source, bottom is drain. Make sense? So now same here. So I'm going to click on the ruler. And then I want to measure the, let's say I'm looking at here, right? This is 17 nanometer. And then the gate length is 25. So actually, the project we sent you was because it was based on our TED paper, right? We actually have this dimension because we try to push to more advanced technology. But we might not have done the best thing for SRAM, right? So now then go back to your question. In the project you mentioned why there's no SRAM structure, because we ran it in another project already, and then we bring it back to there. So for here, what you need to do is, what you can do is just copy this structure instead of run it from there. You also can rerun it from there. It's up to you, right? But you can create the SRAM, just use this project. So for example, I already created after running this for a few hours, right? Yeah, this is the example library. So that's why I want you to look at this one, right? Look at the example library, but use V release, right? Go to memory and then SRAM FinFET 25 nanometer. Correct. Yeah. Now, so this is just the beginning, right? I want you to play with that, but then we need to modify the layout. I assume you are interested in this. I'm pretty sure that you will be happy and excited to change this layout to the right dimension, make it a smaller cell for advanced technology. Yeah. So in this project, you are doing from particle physics all the way to layout design. In that sense, right? So there's lots of things to learn. So yeah. So now you might start seeing what happened. You see, we have different. If I hide all of them, I right click, I hide all of them. Remember, you in the command file, right? What you are seeing now is, yeah. So we were lazy. We try to keep the same file. So what you are seeing now is, if you look at the file, you also see this mask PS1, PS2, PD1, PT2, right? You have different source and drain, but the one you are running was just a transistor. Why it has so many things? That was because it just copied whatever we had from here, right? You have PD2, PS2, meaning the pull down transistor 2, right? Pull down transistor source, right? So this that's why you have those things. So I think since their project doesn't have problem, right? I run it in V release. So I think maybe it's time you just go ahead, instead of using this simple structure that we have here. Can you go ahead now, and you can reproduce some of the results already, right? Yeah. So I actually would like you to maybe copy this as process to your FinFET, and then draw a box. You just open this one, right? See what they are drawing, what domain they are using. Do you see what I mean? Draw a box on this full SRAM, right? If I say show all, draw a highlight. I don't know where is where, right? To reproduce this structure and then run it. Huh? To capture it, yes. You might then also want, after that, maybe change the dimension, right? But draw a box first, run through it. I hope that then you don't run into that error. The error that you show me, right? I would like to use the V release because of convergence and also the support, right? If they have a but they don't care in the old release, they say you just use the new release. So I would like you to use the same layout, use the same process flow. If you run it, it should work. And then draw a box. No need to be exactly the same, but capture, approximates the right domain to run the NMOS simulation. If it works, that would be great. Then we will just change the layout to what we want. Make sense? So again, take a look at this menu. Just go through it one time. It's not difficult. It's very user friendly for this tool, right? It tells you some basic thing, the markup file, etc. Go through it, right? These are all the box. I just say highlights, right? If you draw a line, it will do 2D simulation. You draw a box, it will do 3D simulation. You even can use stretch. You don't need to redraw the layout at this moment. If you have one single transistor, you can shrink it or stretch it, right? And you can rename it. Okay, now I see it. Rename the markup, right? Open here, open cell, SRAM highlights. Do you see this? And then you can just either right click or just double click to rename it. Yeah, so now I can rename it, right? Say TS, right? Then you become test. And then you can call it from S process. Okay? Yeah. So very good, right? So try this. I feel this is a very interesting project. So try that. Yeah. Any questions?